Unit 4, Section 13.3 Worked Examples. Determine two different Hamilton paths in the following graph. Remember, Hamilton path goes through each vertex one time. Keeping that in mind, I can eliminate one of the answers right away because answer A is going through vertex A twice. And let's take a look at the other answers. And it says select all that apply, so there may be more than one correct answer. So let's take a look at the second one. I'm going to trace it on the graph. So it says start at A and then go to E, and then from E go to C, from C go to F, from F to D, to G, to B, and we're good. We've hit all the vertices, so that's a possibility. Let's take a look at the other choices. So let's try C. So C says start at A and go to E, then go to C, and then it says go back to E, which doesn't make any sense because we're hitting vertex E 2 times, so that's not the correct answer. So we can eliminate C, cross out C, and let's try D. So it says start at A and go to E, from E go to C, from C go to D, from D to G, G to B, B to F, and that one would work also, so that's also a possibility. And we've got one more to check because it said check all that apply, so we'll see if possibly E might also be a Hamilton path. So it says start at B and go to G, and from G go to D, from D go to F, to C, and to E, but you notice I haven't picked up vertex A, so I can eliminate choice E. That's not a correct answer. So there were two correct Hamilton paths here, B and D. Now we're going to do Hamilton circuits. And remember that Hamilton circuits start and stop at the same vertex. So let's take a look at the answers and see if I can eliminate any before I even begin. And I can eliminate B because I notice that it starts at vertex B and ends at vertex F, and that would not be a circuit. So let's try the first choice, A. It says start at A and go to B, from B go to C, from C go to E, from E go to G, G to F, to D, to A, and I've created a circuit, so this is a correct answer. And we want to find a second one, so let's take a look at the others. So let's try C. It says start at A and go to F, from F go to G, from G go to E, from E go to C, from C go to B, and then to A, but we haven't picked up vertex D, so that's not a correct answer, so I can eliminate C. And then let's try D. We're going to start at F, and we're going to go to G, and then it says from G go to C, which I can't do directly because there's not an edge between those two. So I can eliminate D. And let's check the last choice. We're going to start at A and we're going to go to D. And then we're going to go to B, to C, to E, to G, to F, and to A. And that is also a Hamilton circuit. So the two answers here were A and E. Sally lives in City A and works for the Department of Transportation. She needs to inspect the way stations in 8 different cities. In how many ways can she reach 8 of these cities and return to her home in City A? So the problem involves 9 cities, her home city plus the 8 cities she needs to visit. Each route she can take is a Hamilton circuit that starts and ends at her home city of A. If n is the number of cities, then the number of Hamilton circuits is n minus 1 factorial. And in this case, n equals 9, so 9 minus 1 is 8, 8 factorial. And if your calculator has a factorial key, which my calculator here does, here's my factorial key, I'm going to put in 8, hit the factorial key, and I get 40,320. So there's 40,320 ways that Sally can start in her hometown of City A and travel to those 8 different cities. Kristen has to pick up her children who all attend different schools. She is at home and needs to go to the Child's First Preschool, Brandon River Elementary School, and Stevens Middle School. Kristen estimates the time among the locations as follows. H to C is 10 miles, H to B is 5 miles, H to S is 12 miles, C to B is 9 miles, C to S is 20 miles, and B to S is 11 miles. Answer parts A to C below. Represent this traveling salesman problem with a complete weighted graph showing the distances on the appropriate edges. Select the correct graph below. So let's take a look. They all show four locations, the three schools rather, plus her home. And then let's look at the distances that are shown. They're all showing the distance between home and the Children's First Preschool is 10 miles, and also the distance between her home and the Brandon River Elementary School. But then if you notice, graph C only shows then a third distance between home and it doesn't show the others. So we can eliminate graph C. And likewise, we can eliminate graph B because it doesn't show the distance between home and the Stevens Middle School across the center there. So the correct graph is graph A. There's the complete weighted graph. And since there's four locations, the number of Hamilton circuits is going to be 4 minus 1 factorial or 3 factorial, which actually is, I pull my calculator over here, 3 factorial is equal to 6. So there are 6 different Hamilton circuits. And what I did here was go ahead and write out those circuits and calculate the distances. And just to give you an idea how I did that. So for instance, on the first one, it's going from H to C. So H to C is 10 miles right here. And then it goes from C to S, which is 20. So there's 30 miles. And then from S to B, which is 11. So now we're at 41 miles. And then finally from B to H, which is 5, and that gave me a total of 46 miles. And I went ahead and I figured out all 6 of those Hamilton circuits along with their mileage here. And so then it says which ones are the shortest. And because I've done all the circuits, all the Hamilton circuits, I already know here's my 2 shortest distances at 42 miles. And in terms of the answers, that happens to be answer B. And then the last part of the question asked me, what is the minimum distance that Kristen can travel? And the minimum distance is 42 miles. And I should also mention that the 2 that are the shortest distance are actually just reverse circuits of one another. So that's why they come out with the same distances.